Hello viewers, this is Dr. D. Rajalakshmi, Associate Professor in CSE Department of RMD Engineering College. Welcome to today's session about backtracking technique with N-Queen's problem. First, I would tell you the general principle of backtracking technique. Then we would see an example for backtracking technique. How to tackle difficult combinatorial problems? There are two principal approaches to tackling difficult combinatorial problems, that is NP hard problems. The first strategy is use a strategy that guarantees solving the problem exactly but doesn't guarantee to find a solution in polynomial time. The next one is use an approximation algorithm that can find an approximate or otherwise suboptimal solution in polynomial time. These are the some of the strategies available for finding exact solutions. The first strategy is, or the first technique is, exhaustive search technique. It is otherwise called as brute force technique. It is useful for solving only smaller instances of the problems. Then the next technique is dynamic programming technique. It follows principle of optimality, so it guarantees for the optimal solution always. It is applicable to some problems, for example, knapsack problem, traveling salesman problem, etc. The third technique is backtracking technique, and it eliminates some unnecessary cases from consideration and yielding solutions in reasonable time for many instances, but worst case is still exponential. The next technique is branch and bound technique. It further refines the backtracking idea for optimization problems. Let's see about backtracking technique. What is backtracking technique? What is its principal idea? Actually, backtracking technique uses state space tree for solving the problem. It constructs solution one component at a time. Evaluate each partially constructed candidates as follows. If a partially constructed solution can be developed further without violating the problem's constraint, it is done by taking the first remaining legitimate option for the next component. If no legitimate option for the next component, then the algorithm backtracks to replace the last component of the partially constructed solution with its next option. Finally, if the algorithm reaches a complete solution, it either stops or continues searching for other possible solutions. Now let's see example problem, that is N-Queen's problem for backtracking technique. Here what is N-Queen's problem? It is a problem of placing n number of queens on an n by n chessboard so that no two queens attack each other by being in the same row or in the same column or on the same diagonal. Now the given problem is the 4 queens problem, because here 4 by 4 chessboard is given, and apart from that, along with the chessboard, 4 queens are also given to us. We have to keep all these 4 queens on the chessboard such that no two queens attack each other. So these two are the solutions available for 4 queens problem. Now we are going to find this solution using backtracking technique. As we know already, backtracking technique uses state space tree. State space tree in the sense it is going to be the solution space, the tree representation of the solution space of the problem. That is what is called a state space tree. Initially, no queen is placed in the chessboard. This is the initial state of the problem. Now, the first queen can be placed only in the first row, second queen in the second row, third queen in the third row, and fourth queen in the fourth row. For placing first queen, we have 4 options. We can place first queen only in the first row. The first row contains 4 columns. So 4 options are available, 4 valid or legitimate options are available for placing the first queen. This is what is the first component of the solution. Position of the first queen or column number in which the first queen is placed is the first component of the solution. According to backtracking technique, we are choosing the first legitimate option for building the first component of the solution. That is, we are keeping the queen in the first column of the first row. Now after keeping this one, in the next step, we have to place the second queen in the second row such that no two queens attack each other. Already one queen is available in the board. Without we have to keep the second queen without affecting the first queen. Here, a second queen can be placed only in the second row. Second row contains 4 columns, but in the first 2 columns we cannot keep the second queen, because if we keep the second queen in the first 2 columns of the second row, it will affect it will attack the first queen in the first row. So only 2 legitimate options available for keeping the second queen. We are taking the first legitimate option, that is column number 3. We are keeping second queen in the column number 3 of the node 2. This is what is the node 2. Okay. So we are keeping it here. Then we have to keep third queen in the third component or third row. So this is the third component of the solution. We have to keep the third queen in the third row. Is there any legitimate option available for keeping the third queen? No, not at all. So we are unable to proceed this. So what your backtracking technique will be doing means, it will be considering this node as a non-promising node, and it will backtrack to the previous node itself and will replace the last component with the next legitimate option which is available. So we are keeping second queen in the 4th column of the second row. This is what is the next choice available for keeping the second queen. So after keeping this one, is there any option available for keeping the third queen? Yes, only one option is there, that is in the third row. Second column is possible. So we are keeping third queen in the second column of the third row. Now after this one, we have to build the last component of the solution. That is, we have to find position for the 4th queen in the 4th row. But unfortunately, there is no legitimate option or choice available for keeping the 4th queen in the 4th row, because it is not possible. The queens will attack each other. So what your backtracking technique is doing is, it is backtracking to the previous step, searching for other legitimate options for third queen. There is no option available, only one option available. We had only one option, we tried that, we are unable to find the solution. So it is going up to the previous step. Here it is searching for the option for second queen. Here also there is no extra choice available. We had only 2 choices for second queen. We tried both the choices, we are unable to find solution. Now your backtracking technique is going up to the very first step itself, and it is replacing first queen in the second column of the first row. It is choosing the next choice available for the first component of the solution, that is the second column of the first row. Now we are creating node number 5, okay, and we are keeping the first queen in the second column. Now the second component of the solution we have to build, that is, we have to keep the second queen in the second row. Only one option is there. We cannot keep the second queen in the first 3 columns of the second row, because the first queen will attack. So we are keeping second queen in the last column, that is 4th column of the second row. So second component of the solution we built. Now we have to build the third component of the solution, that is, we have to keep the third queen in the third row. Okay, how many options available? Only one option available. We can keep third queen in the first column of the third row. We are keeping it here. Then after this one, we are trying to build the next component of the solution. Your backtracking technique is searching for the legitimate option for keeping 4th queen in the 4th row. It is available. One choice is available, that is third column of the 4th row. It is available. So in that third column of 4th row, the 4th queen is kept. So we found all the 4 component of the solution. So this is what is the solution of the given problem. That is, node number 8 represents solution of the 4 queens problem. So this node can be called as solution state. With this discussion, we are finishing today's session. Thank you.